Good day, I'm Dr. T and welcome to my desktop. So today I want to talk about graphing and kind of go over the three bread and butter style graphs, the ones that we in general use the most. There are other styles of graphs that are used quite heavily depending on what particular discipline you're doing and what subfield you're in, because every subgroup will have its own preferences. But the three graphs I want to talk about today are by far the most common, and I'm going to end with the most common of them. I'm going to start with pie charts, which are probably the least common, to be honest. But they're a nice, easy one to start off with. I am using the Microsoft Excel app for Windows. If you are using a different spreadsheet software, it will look a little different, maybe noticeably different, but they're all relatively similar. I definitely know there's a difference between Excel for Windows and Excel for Apple products, and then the web client looks a little bit different as well. Google Sheets and LibreOffice are also going to look a bit different, but if you know how to use one, generally speaking, you can get the rest with a bit of poking and prying and maybe the occasional Googling. Okay, so I've just got some made up data, and the first one I want to do is a pie chart. Now this one of the reasons it's relatively uncommon is that you have to have very specific data in order to work with this one. Basically, it has to be fractions of a whole. So all of your numbers adding up need to add up to a total. So basically, you're dealing with percentages. So over here, I've got micronutrients. That's going to be my independent variable, and then calories consumed today. So obviously, these are kind of where my calories are coming from. So the total of this would be my total calories today. Once again, I just made this number up. I don't know what I've eaten so far. But this would be my dependent variable. So that and factoring in just how much I ate kind of thing. So easiest way to do this one, and this is kind of the easy way to do a graph. I'm going to keep the pie charts relatively simple. I'm going to highlight these guys. I'm going to go to Insert, and I'm going to pick the pie chart. Now, I've got options, but I am just going to stick with this one. Just go for the old-fashioned. You don't need to get fancy on your pie charts. Now, this one actually has a bit of a problem. One, maybe I want a little bit more precision going on. That might be nice. Maybe, maybe not. But this is definitely has an accessibility issue. Not everyone can see colors well. Color blindness is very much a thing, and if someone was colorblind, it would be very difficult for them to identify this chunk as the protein, this chunk as the carbohydrate, and this chunk as the fat. They might be able to get some of these. Most people who have an impairment with their color vision are not completely black and white, although some are. But if you kind of treat it as if everyone viewing this will be viewing it in black and white, it's going to work well. So all I need to do is just kind of change this just a bit. So one, I want to accentuate these guys where I've got kind of the border, so not just touching, and then I want to get some labels going on over here. So I'm going to go to the quick layout, and I'm going to look for something that's got some labels on it. Now, this one's, it's getting better. So I've got the total numbers. Maybe I want percent, maybe I want total numbers. That's up to you. You know what, I want percents, to be honest. I just like that a little bit better. But notice how they're currently in here. There's a contrast issue. Once again, if I'm honestly, I have no color blindness issues myself, and I'm having problems seeing this. So I want to change this up a bit. This would be an option where I kind of black box it. And I'm just going up into this chart design and looking what I like. This one's going to change up the contrast a bit. Yeah, frankly, I find it looks ugly. This one's probably a bit better. This one's probably good enough, but I'm going to kind of look around for maybe some better ones. I'm just sorting through these guys. Once again, that one actually, I kind of like that one. But if I got anything else, you know what? I almost like that one. It's always interesting trying to get the one you like and get it optimized. And of course, the more you play around with it, generally the better it gets. I'm just going to leave it at this one. I think that gives me enough contrast to be fine for all viewers. By the way, I don't need that key. Each one's labeled, no reason to waste space. And so now I've got my graph. I can insert it someplace else. To be honest, a lot of the times we're not going to put a title on it either. We will more than likely in the document that we input it into go ahead and put a figure caption, say, figure 5, and then give it a title and then a short description, or whatever happens to be in this one. So if you're going to do that, you get rid of the title for the thing. If you're not going to, then obviously you want to keep the title. Okay, so that is a pie chart, fairly straightforward. I'm going to make things a little bit more interesting with a bar graph. Let's go ahead and just kind of zoom in a bit, just make it a little bit easier to see. Okay, so in this fictitious one, I've got cultivars, that's basically types of plant. In this case, I've got types of apples, and I'm dealing with 3 types of apples. And apparently I'm comparing a bunch of different trees. So maybe this is like if I've got an orchard and I'm comparing the yields of my trees. Okay, so first off, looking at this guy, I've got 6 trees of each type. It'd be really helpful to do an average. So I'm going to go to this box and I'm going to put in an equation to give me an average. So I'll do equal sign, and then I'm just going to start typing average. And I'm going to click average, double click average, and then highlight the things I want to average. I close the parentheses, and I'm going to hit enter. Okay, I don't need all those sig figs. That's kind of ridiculous. If I am displaying this table, I would definitely want to gussy this up a bit. I'm just going to right click, that gives me this menu. I'm going to format cells. I'm going to say this is a number, and I want maybe no decimal places. Okay, so I've done that for this one up here. I can do that the same way for each one, or I can simply go up here, see this little dot, see how this little square and how my cursor changes. At least hopefully you can see how the cursor changes. And I'm going to double click, and now that runs that equation on these guys. So now I've got the averages. I've got multiple trials. It would be nice to get kind of a general spread. What kind of spread am I dealing with? And typically we do this with what we call standard deviation. And oh, look, I have a typo here. Average per tree 7, average per tree. Okay, fix that typo. Okay, so standard deviation is a mathematical description of basically how close together are your data points. So, like, these trees are all over the place. You've got kind of a range going on here, but they're kind of all over the place. So it might be nice to see what the spread is. And if I was smart, I would have made one really tight and one really narrow, but I didn't really think of that. So I'm going to hit equal. I'm going to start typing out. Now, I've got standard deviation. I've actually got 2 choices. So I've got standard deviation, and this is going to perform the calculation. And this is if that's the entire population. So I've got 6 trees here if that's all the trees I have of that type. So if I have 6 Granny Smith trees and I am putting them all in there, then I would pick this one. If, on the other hand, I had a bunch of Granny Smith trees and I've just picked 6 as a representative sample, well, then I would do the standard deviation .s or .sample. Let's say I only have 6 of each tree. So I'm just going to do this one. And then I'm going to highlight these, not the average. And once again, way too many sig figs. So I'm going to format this cell. You don't actually need to. If you're only going to have the graph and you're not showing the table, there's no real need to reformat this. But it's not a bad habit to get into. Okay, so this one spreads a little tighter on the Granny Smith than the others. The Golden Delicious seems a little bit broader spread. I might want to do relative standard deviation, in which case I could take this guy and then I could divide it by the average. This is a nice way of dealing with this, and relative standard deviations are often a percent. So I would change this to a percentage, say 1 decimal place. So yeah, I could do that if I wanted to. I'm not going to use that in the graph. I will use the standard deviation. I'm going to show you how I do that. Okay, now I can't just highlight this one. Actually, I can. I can highlight the trees. I can hide them. Then I can just highlight it. But I'll show you how you do it when you're not just going to highlight it. So first I'm going to go insert, and I'm going to do a bar graph, or Excel calls them a column graph. Oh, now they're calling it column or bar chart. They used to call it, they had 2 separate ones. Okay, once again, we're just going to keep it simple. There are times to use these fancier ones. Basically, if there's nothing you're gaining from 3D, don't use it. Sometimes there's a reason to do 3D. Not today. Usually just use the boring one. I know, it's dull. Okay, at this point, I've made several edits, so I'm just going to jumping back after the silly mistakes. And we have no data yet. So now I need to get some data in here. So I can right-click on this guy. I'm going to do select data. I'm going to say add. I need to add in a series. So I'm going to select the range. And it's just going to be my 3 topics in this case. Once again, it could be more, it could be less. I'm going to hit enter and get back. Now I'm going to do the series values same way. I'm going to press this little up arrow. I'm going to click it. I'm going to highlight my averages. And I'm going to hit enter to get back. I'm going to go OK. Now, I need to get some labels on these things, so I'm going to hit edit. And then I'm going to hit the up arrow to give me the selecting tool. I'm going to highlight them. I'm going to hit enter. I get that. I might as well just hit enter to go again. And then I will hit enter to get back. No, I won't hit enter. I will hit OK, not enter. And boom, I've got this. Now that title is kind of a mess, so I could either reword that, or if I'm going to input this into a paper, I'll just make it go away. Also, let's just be blunt. Those lines, don't care. Let's make those go away. And the way I'm going to do that, I'm going to click on the horizontal lines, and I'm just going to hit delete. I'm going to make those go away. Now, let's modify this. I'm going to add chart element. And I am going to go through and I'm going to find error bars. I'm going to do standard deviation. I'm going to click on that. And then right now it's just defaulting to 1, but that's not going to be accurate. So I'm going to right click on here, format error bars. I basically clicked right on an error bar. I'm going to go over and right click on it. Typically with bar graphs, we just do plus. We don't do both. We do like the little cap, and we're going to do custom, and we're going to specify the value, and the value is going to be this one, and it's the same for both directions. And we'll hit OK. Now, this basically pops up and implies you've got an error from here, and then once again going down. If you want both directions, you can do both. It's usually just kind of hard to see. Now, I set up this data so that they're all about the same, which is not maybe the best I should have done. I maybe should have had one of them be all kind of wonky and the other one be like really tight. But basically what this is saying is that if I did more of them, I've got a pretty good confidence that they generally are falling in this range. Quite often when we're looking at 2 bars and say, okay, well, are the Golden Delicious and the Fuji's meaningfully different? Well, not really. I mean, the Granny Smith is not incredibly different. The error bars still overlap. So the difference between these is not a ton. Now, if I maybe had a bit tighter on the Granny Smith, this one's pretty clearly a bit less. So maybe if I tighten things up, I have a better quality control. This would be a little bit tightened up. But then again, maybe that's just how my orchard works. Maybe my trees are all scattered all over the place, and some have lots of water and some don't, and you know, good dirt, not so good dirt, or I guess I should say soil. But you get the idea. So the error bars tell you what kind of spread you've got by just kind of looking at it. Now, if I'm looking at it over here, if I look at this axis, like that's an awful lot of numbers. So what I can do is I can kind of go over here. This is telling me how far apart they are. They're every 50. Maybe I want to have them every 100 kilos. And so now those are about a little bit better spaced off. But also you don't know looking at this what this is. So let me get into chart design and let's look at a quick layout. Something that's going to be a little bit different. Give me some axis labels. And of course, it's not giving me one with a nice set of axis labels. Okay, here's axis titles. Yeah, there we go. Okay, so I don't really need this. That's not helping me. I'm going to go ahead and get rid of the error or the crossbars over there. They just clutter things up. They're not that helpful. So my axis label here, and if you notice I'm aiming to the side, that's because that's my camera's right in the way. So I'll just give this a title. Hopefully I spelled that right. And this title will be kilograms per year per tree. I don't like it, but it's good enough. And once again, that's not actually that helpful. And my error bars went away, so I get to add the error bars back in. So you get to watch me do that again. So I'm just going to put that in there, click on an error bar, right click on it, select the data. Nope, wrong one. Format error bars. And then over here, I'm going to go custom, specify values, and I'm going to specify them over here. No weird little plus sign. And once again, typically we only do the positive cap, assuming they're symmetrical, which generally speaking, we're going to have symmetrical error bars. Okay, so here's a nice little bar chart. Always a classic. Generally speaking, I've got my dependent variable over, sorry, I have my independent variable over here. I've got my average dependent variable over here. When I'm using a bar chart, my independent variable is going to be some kind of just thing. It's not going to be a numerical value. But my dependent variable will. So this is the type of cultivar, whereas this is the, the yield per tree. And so I can just leave that. And actually, you know what? Maybe I should call that yield. Yeah, that looks less hideous. Not per. I don't know why I'm being so obsessed with making this look good, but still did not succeed. Okay, there we go. So with that said, I'm just going to move on to my next one. The last one is the XY scatter plot, and this is by far the most common one that we use. Okay, so in this case, this is going to be a calibration curve. So in a calibration curve, basically you're taking one property that you know what it is, you're doing an experiment on it, and you're finding another property that you then will know what it is. And the reason you're doing that is because one of these two properties, you're going to do it on another unknown sample where you don't know one, and you're going to have to use the other to solve for the one you don't know. So in this case, this would be for a spectrometry experiment. We're going to use what's called Beer's law. Beer's law is basically saying the absorbance, a logarithmic function of how much light does not make it through a sample, is proportional to the concentration, and in this case we're doing millimolar, times what we call an extinction coefficient, which is basically how good that chemical at that wavelength of light absorbs light, and then times the path length. So what we've done is we've taken some kind of chemical, we've made different concentrations. We probably did what we call serial dilution, where we started out with a concentrated one and we just kind of split it apart, added water. Scenario, and then we've measured it. So odds are really what happened is I made 3 different 2 millimolar solutions and I measured each one. So this is not the same one 3 times. This would probably be 3 different solutions. So you can imagine if I did this, I probably made 16 solutions. But you know what? If you want good quality, you want to repeat it over and over again. Okay, so I'm going to do average. So I'm going to do average. And then just highlight the numbers and go ahead and just hit down. And I had actually already gone through and formatted these, so they're all 2 decimal places. If you don't do that, it's not going to quite look the same. And then I'm going to do standard deviation. Now, these are definitely parts of a whole. If you're working with chemicals, you're probably not using everything totally. So it's almost always the standard deviation S that you're going to use. And then I'm just going to highlight these guys. And same basic story. I could do relative standard deviation. I'm not going to. It's not particularly needed. Okay, we're going to plot this. So I'm going to do an insert. Now, it's tempting to think line chart. We almost never use line graphs in the sciences. Occasionally we do. Generally that's going to be like a time-dependent thing, like growth rate per month or something like that. Really big in business. In the sciences, we're going to use XY scatter plots. And generally speaking, we don't connect the dots. We're going to use this one. Once again, if in doubt, pick the boring plot. Okay, so now I'm going to do the plot here. And once again, I need some data here. So I'm going to go over here. I'm going to select data. And I'm going to add, and so I'm going to take the X value, and this is the X value. And then I'm going to click here and cover this one. I'm just going to hit the return key, and then I'll hit OK here. And I'll hit OK here. Boom! I've got myself a nice plot. Now, I'm going to move this up here, just make it just a smidge larger. So I want to gussy this up a bit, but first let's do the quick layout, and I'm going to get titles and whatnot going on. I only have one thing on here, so I don't need a legend here. So that's not needed. Let's see. Once again, I don't want these lines going across. They just kind of clutter things up. And odds are, you know what? I'm going to be giving it a title as a figure caption, so I probably don't need the title there. Sometimes you will leave the title on there. Just a lot of the times you won't. So over here, I'm just going to kind of put these guys. I'm just going to cut and paste them right into the axis titles. Control C for cut or copy, Control V for paste, and then Control A just highlights everything in that area. So I did that one. I'm just going to do this one. Now, a couple things you'll notice. One, the units for all these numbers, they are up in the titles for the sections or in the chart titles. Generally speaking, Microsoft Excel, most spreadsheet software really wants numbers or letters, not both. And so it won't be able to do the calculations if you put the unit with the value. So you use it as part of the heading. So you always want to move the unit up here in the title section. Okay, now odds are what I really want is an equation for this line, because hey, I've created a line. I've got my independent and dependent values are both numbers, so I could, hey, two numbers, I can make a plot. That's what I've done. So I'm going to right click on this, I'm going to highlight, and I'm going to add trend line. Now a trend line is not a connect the dots line. It is mathematically trying to average out, and that's almost certainly the wrong terminology, but it's trying to find a line that gets the closest to all your data points. Now I'm going to go over here. I don't set the intercept. Usually that's part of the information, but I do want the equation and the R squared. Now, if I'm doing this for publication, there's actually a good chance that I don't do this. Or I do this for my own copy and then I delete this part for publication. So if it's a very formal publication, I will probably have this in the text, not just floating on the chart. But if it's a casual publication like a lab report or something, it'll probably be just floating here. So that's the equation of the line. So Y, of course, is this. That would be the absorbance. X is the concentration. And so now if I know the absorbance, I can solve for X. The fact that my intercept is not at the origin tells me I've got a little bit of shifting in my data. Okay, so now I want to clean this graph up, just make it look a little pretty. Once again, let's format this axis. That's a lot of numbers. I don't need them that far or that close. So let's go, I'm going up to 0.8. So if I did every 2, that would work well. Yeah, that seems reasonable. Once again, down here, 2 seems a little bit low. Maybe I could go to 5. Also, I don't need to have this going all the way to 16. I can have this go to 15. That's fine. Truth be told, I don't need to start at 0, 0. I may or may not want to. It's kind of a part of the story. But like if I was graphing temperature, I wouldn't start at absolute 0. My whole graph would be smushed off to one side. So this is one of those where Whether or not you show the origin as 0, 0 really is contextually dependent. Now, of course, you can also use that to deceive viewers. So you don't want to do that, but you also don't want to have silly numbers. You know, I wouldn't want to have a graph of, you know, the obvious one would be temperature, where I'm doing, you know, growing temperature in Kelvin and have my, you know, plot all skewed over because, hey, you know what? My plants are growing at, you know, above freezing of water. So, you know, I've got 273 Kelvin that I'm just not using. So I wouldn't do that. I can do error bars on this one as well. So I'm going to go over here, chart design, add elements, error bars, standard deviation. Generally speaking, the X error bars we don't really use much. We usually use the Y's. Generally speaking, the independent variable, hopefully I did a good job of figuring out the concentration. And so we're assuming kind of the error is described by the dependent variables one. Okay, this is going to be basically the same. I'm just going to specify the value, and I'm going to do standard deviation for that one. Once again, every time it's jumping, I'm hitting the enter key. And I'm going to highlight that one. I'm going to hit enter again. I'm going to get OK. That kind of cleans things up. And so now you kind of see the trend, you see the equation. You'll notice that this one, there's a bit more standard deviation, as you can see. It's a higher number here, and it kind of looks like that number is the one it's coming from. Now, I don't just make that go away. I can do a Q-test, which I'm not going to deal with in this video. I'll let you look up a Q-test. But if you have at least 3, ideally a lot more, you can look for ones that are mathematically improbable to be consistent with the rest. So basically, if you got a nice tight spread, but you got one random one just completely off in left field, you can mathematically justify just making that one go away because clearly something was wrong with it. You cannot do that based on your own personal vibes. You either need to have an articulated reason why that is not right. Like, oh, wait, I remember that particular one. I think I spilled it. Or I used a bad test tube. Okay, well, why did you do that? But make it go away. It's not valid. You know why it's not valid. Or you could do a Q-test, which tells you the mathematical probability that it's valid or invalid. But without one of those two, you have to leave it in. Otherwise, you're cherry picking. Okay, so those are kind of the 3 main ones. This one is our bread and butter. This is probably the one I've made by far the most of. 9 times out of 10, I'm just looking for that equation. Which you can also get, you know, just in case you want. You can do intercept. And you can highlight your numbers, known y's, comma, known x's. And there's your intercept. Hey, it looks familiar. Not quite. It's almost the same. Odd. Then you can do slope. Known y's, comma, known x's, boom. Okay, I'm probably just going to cut this part of the video out. I don't know why. No, they're fine. Yeah, they're good. This is just a rounding. Okay. So yeah, so we've got our slope, or maybe I can call it the M, and that's my B. So I can solve for it this way if I would prefer. Okay, let's do one more graph, and let's do a little bit of data processing. So over here I've got some information about a bunch of chemical experiments that, you know, hypothetically would have been done. Once again, this is all just made up numbers. Okay, so in this one, some kind of reaction was taking place on some chemical, and chemical A and chemical B. So we're comparing 2 different chemicals, and in the process they're losing mass. So maybe they were giving off a smaller molecule probably, so giving off something likely as in the form of a gas. Who knows, though? Once again, it's all made up. And so we're comparing this. And what I want to do is I want to graph, in this particular case, percent mass loss versus time. Okay, so let's go ahead and do this. So I've got the mass lost. So I'm just going to do an equation. So I'll hit equal sign. And then I want the mass that's lost, so the difference. So I'll just do the starting mass minus the ending mass. So normally we do a delta, it's final minus initial, but in this case we're looking at what's lost, so we'll do initial minus final. And so then I'll just click on that equals enter. Once again, I just equal hit the equal sign, and then I click on the number I want to start with. I do my operator, in this case it's the minus sign. I click on the next number. I'm done. I hit enter. Now, I could do that for all of them, but I'm not going to. So what I'm going to do is I'm just going to look at this little square. You got the box around, and there's a little tiny box in the lower right-hand corner. I'm going to double click that. That's just going to kind of fill in all of these guys. And what it's going to do is, as it's doing this, it's going to progress the numbers over. So every column has a letter, every row has a number. And so if it's going down, and say, well, if it goes down one box, I'm just going to take all the numbers that are in there and I'm going to add 1 to them. So I'm just going to make it go down 1 box. Now, let's say I don't want to do that. If I didn't want to do that, I would put a $sign right before the number. A $sign right before the letter will mean it doesn't change the letter. $sign before the number, it doesn't change the number. Now, I don't want that, so I'll leave it alone. And then I'm going to go ahead and I'm going to do the same. If I can cut and paste, so Control C, Control V, you know what? It's going to do the same thing. It's just going to kind of keep pathing them along. And so now I've just filled them all in. So I'm going to do the same thing for percent mass loss. So that's going to equal mass loss divided by the starting mass. And I'm just going to equal, click on the mass loss cell, do divide by, which is the slash. I think it's a slash. It's the 1 by the shift key or the 1 by the numlock key. And then once I've got my equation entered, I hit enter. This is editor me here. There has been a few takes on this, and I left something out of this particular take, and that is what your standard for functions are going to be, because a couple of them are a little bit counterintuitive. So addition, subtraction, pretty obvious. That's the plus sign, which is, you know, with the equal sign on the keyboard, so shift equal, and then subtraction is the dash, so the button next to the equal sign or above the plus sign on the numpad. Multiplication, that one is the one that can throw a few people. That one is the asterisk. So we're looking at shift 8 or above the 9 on the numpad. And then division, as I just mentioned in the video, is going to be the slash, which is the next to the shift key with the question mark, or above the 8 on the numpad. Okay, back to the video. I had already formatted this in a previous take that I scrapped, but if it wasn't edited the way you like it, you go to the format cell and then you pick what kind of formatting you want to do. In this case, I want percentage with 1 decimal point. Okay, so in that case, I can click and drag instead, so I don't have to double click. I can just click and drag. Now it's going to give me this divide by 0 because it's treating any empty box as 0, and well, that box is empty, so I'm just going to get rid of it because that's just a space. Now I want averages, because of course I do. So I'm going to do this like I've done earlier. Call up the equation. Double click, highlight the ones I want to average, close parentheses, and then I'm just going to cut and paste these. Once again, the reason this is percentage is in the last time I edited these, I had changed the formatting to percent. And then I'm just kind of plopping them down. Once again, it's changing the numbers depending on where it's at. This is a really powerful feature. You don't have to type in the same equation over and over again. If you're typing in the same equation over and over again, something's very wrong. And once again, I'm going to do standard deviation. And I want the S. The S is if I'm not doing every single member of the population, I'm just doing a representative sample. And I'm just going to highlight the ones I want to do, close the parentheses, hit enter, and same basic story. Okay, so this is a little bit of a mess, so let's go ahead and get this ready to go into a graph. So I'm going to go ahead over here. I'm going to do time. Then I will do average percent mass lost for A. And then I'm going to do average percent mass lost. By the way, you notice I'm kind of making a little bit of a flub here, and this is one thing I forget. Word, when you copy something, it stays in the clipboard. Excel, once you do anything, it leaves the clipboard. Let's see if I can not hit random keys. Okay, and so I'm just changing the titles. Okay, so for the time, 5, 10, 15, I could kind of do some fancier stuff with that one, but there's only 3 numbers there. I'm just going to leave it alone. Average percent mass loss, I'm going to equal, and I'm just going to click on the one that's relevant to me. I could get fancier, but I'm just going to do equal, the one that's relative to. Now, I could cut and paste them, so I could Control C, well, I wouldn't want to do Control B. Control V would put in the equation, but instead I could do paste, and I could paste it in as the number. So this is now no longer the equation, it's actually the number. But I like doing the equal sign instead, because it gives me the same result, except for that if anything changes over here, that will cause this to change, and that causes this to change. And so if I need to edit this in any way, like I realize I typed something in wrong, well, maybe that wasn't 8.6, maybe that was 8.5, well, then it will process and re-edit everything for me. Okay, same over here, and I'm just going to keep on going. There are better ways of doing this if you're doing a lot, but this is just kind of the nice streamlined way. And then, you know what, let's do standard deviation. And this will be standard deviation A and standard deviation B. Okay, and I'm just going to do this the same way. No, I'm not going to try and do anything fancy. There. And so this is making my life a little bit easier. And you can get a lot fancier with your formatting if you want. Generally, nope, wrong button. By the way, if you make any mistake, Control Z is your friend. It undoes whatever the last thing you did was. Okay, so I'm going to go ahead and insert the graph. So insert, I've got numerical values all around. So I'll do XY scatter plot. I'm just going to put it up here, partially because right around there is where my camera is and I can't see the screen. Speaking of can't see the screen, select data. Let's see, I'm going to add the first series. That'll be A. And I'm going to go to X values. I'm going to hit that little up arrow. And I'm just going to highlight them. I'm going to hit enter. And the Y values, I'm going to hit that up arrow again. And I'm going to go for the Y values. Boom. And I'm going to hit OK. And then I'm going to add another one. And so this time I'm going to put in 2. I'm going to do A and B. Now the X values are the same. They don't actually have to be. But generally speaking, it's not a bad idea. And then the Y values are going to be different. Okay, and so that's all good. I've got myself a graph. I'm going to go ahead and start gussing it up. So I'll put that in. I'm going to go ahead and put the error bars in. And now I get to kind of clean up things. So let's get rid of those. Let's get rid of the horizontal error bars. Let's go ahead and format those error bars to get the right values. That looks like I'm on the A. No, I'm on the B one. So I'm going to do custom specify values. And then I'll do the A, specify values. Okay, I have relatively small error bars, which is kind of nice. And then I'll go ahead and put in my trend lines. By the way, the order doesn't really matter. Generally, I do equation in R squared. If you're being all fancy, you might not do that, you know. Okay, I'm going to start labeling things in here. So it's time. I'm going to do that in seconds. Percent mass loss. I could say average percent mass loss or just percent mass loss. It's kind of implied an average. By the way, that's kind of in the middle of nowhere, so I'm just going to clean that up. Okay, last part, title. So title would be something like, it's usually Y versus X. So percent mass loss versus time. Okay. So yeah, there is a perfectly legit graph. Now, let's say I want to be a little bit fancy. I want to get this and move this over into a Word document. And I'm going to make this into maybe a little bit fancier report. Well, actually, I've got one thing I've got to do first, and that's an accessibility feature. Notice how the orange and the blue are both dots? That's not okay. So I need to go to at least one of them. Click so that I'm on the dots. I don't want the trend line. This is sometimes a little bit finicky to get. Maybe I need to make you bigger just so I can hit the number. Not the trend line. Okay, if you can't click on it, you can go up into this menu and go find the thing you want. So series A or B, it doesn't matter which. I'm going to go to this chart one. Marker. Okay, so paint bucket, marker. I always have to poke around and never remember which ones are which. Marker options, built in, and then I'm just going to pick something that is not a dot, something that's a little bit more noteworthy. So okay, I've got this kind of triangle. That's the size, so I can make it bigger or smaller if I want, you know. Okay, and I can click off. Now A is a triangle, B is a circle, and that way someone who can see it but cannot distinguish the color can distinguish between the two. Or it's just been printed in black and white. Now, if I want to move this over into a Word document, I've got a couple options. One, I can just go ahead, pull up my Word document that's sitting down in the corner. Control C, Control V. Boom, it's in there. But if I want to make this fancy, let's gussy it up a little bit first. So I'm just going to go ahead, and actually I can do that in the Word document usually. I'm going to get rid of those guys. And you know what? I'll leave those, although quite often I would not. Okay, so what I'm going to do is I'm going to label it Figure 1, and I'll give it the title here. So I don't know why Grammarly is not poking up, but percent mass loss versus reaction time. I got to move this out of the way because my screen is once again. Okay, so I had to move that out of the way just because the camera is in the way. Okay, percent mass loss versus reaction time. And then I would say for, I give my two chemicals. A. Now, in these parentheses, I'm going to put these symbols. I can try and sort through the symbols input part into Word. It's always frustrating for me. So quite often, I just go ahead and Google that. I will pause the video and go put them in. So basically, I'm just going to Google the shape. I'm looking for the Unicode symbol. And then once I find that, I'm just going to insert that. Okay, I'm back. I have those labeled. And I'll probably make that Figure 1 bold, just kind of to title it up. So yeah, I've got this guy. Maybe I want to gussy it up just a smidge more. Maybe I want to format the axis, make this, you know, major unit of 5, maximum of 15, just kind of make it look a little nicer. Over here, I could change this up, but I don't really care. If this is going for more of a presentation, I'd probably put this information in the body of the text. So I wouldn't really leave that there. So those would probably go away. This looks kind of streamlined, but you know, that's fine. Okay, so with this said, that could go very nicely. I would put the trend lines, etc., in the body of the text. But otherwise, yeah, here's a graph. So with that said, have a wonderful day, and I will see you in future videos.